So in previous class, we are discussing about substitution reactions, right? The students has to join. Why most of them are absent today? It's still raining outside. Then or they are in week off mode. From weekend, anyone joined? Someone respond, please.
Yes, sir.
From weekday,
Yes, sir.
Yes, sir.
weekday students.
Yes, sir.
Oh, one student joined. Right, sir. So in previous class, we are studying about substitution reactions. Whichever have negative charge or whichever have lone pair of electrons, they will attack on the carbon, making this X to replace, right? So we have seen in case of KCN, AGCN. It is there already, one or two students joined. No, in chemistry. Wait, not there. Where I posted it?
$20, sir. 323.
Okay. No, this is SR0.
Yes.
Chemistry. Today I posted.
This is the link.
Okay.
Okay.
Again, I will post. I posted. Right, sir. Listen. Yes, sir. Yes, sir. So I told you to remind me about KNO2, AgNO2, right? So I am taking KNO2. KNO2 will ionize readily to form K plus and NO2 minus. In this, negative charge is on oxygen, correct or not? So it is N double bond O, O minus, K plus, correct or not? So which acts as nucleophile now? NO2 minus acts as a nucleophile. It will go and attack over carbon, making this X2 leave, right? So what should be the product? What should be the product, sir? R CH2 O N double bond O, correct or plus KX. Response, sir. Now, instead of this, if it is AgNO2, then what should be the product? What about silver? Same thing happens in case of AgCN also. Response, sir. In case of a silver nitrate, AgNO2, what should be the product? Ag bond, how it should exist? O N double bond O. In case of D block elements, this bond is covalent, so it will not break easily. So which acts as a donor now? Nitrogen. So if nitrogen acts as a donor, product should be R CH2 NO2. Let's stop talking. What is the difference between these two? What is this one and what is this one? We call this as alkyl among these two, which is called nitroalkane. Second one is nitroalkane. First one is alkyl nitrite. And it exists as NO2 minus. So it is called alkyl nitrite. This is called nitroalkane. Next one. I am writing it as R2 prime CuLi. What is this reagent called as? What is this reagent, sir? Yes. What is this reagent? This reagent we use in Corey-House synthesis. This is called as Gilman's reagent. So here R prime acts as a nucleophile. So it will go and attack. So product will be R CH2 R prime. You will get alkane. Correct? Then what is left? R prime Cu is left plus LiX. What is the name of this reaction? Corey-House synthesis. Response, sir. Next. Now I am taking R CO, yes sir, O minus Ag plus. Silver acetate. If silver acetate is allowed to react with alkyl halide, what will be the product? Alkyl halide, silver acetate. What is the product? A preparation of alkyl halides from silver salts of carboxylic acids. We have seen or not? During preparation, what is that? Carbon, simonine, borodine, Hunts-Diker reaction. If it is silver salts of fatty acids to form alkyl halides, various preparations, man. Methods of preparation from alkenes over alcohols. This one only. From silver salts of fatty acids. Silver salts of fatty acids allowed to react with halogen. If it is in 1:1 ratio, what is it called? Borodin-Hunts-Diker reaction, right? If it is in 2:1 ratio, if it is 2:1 ratio, what happens? First, this will form alkyl halide. Then alkyl halide will react with the second mole of it. This must be in 2 moles, no? So when they react, first they will form alkyl halide. Then the second mole will react with alkyl halide to form ester. Name is Birbon-Simonini reaction, right? So product will be RCH2. This acts as nucleophile. O, CO, R prime plus silver halide. Name of this reaction, Birbon-Simonini reaction. So this is about substitution reactions, sir. And we have already seen mechanism of substitution reactions, SN1, SN2, SNI. Where we have seen SNI mechanism? Detergents. What, sir? Alcohols allowed to react with SOCl2. SNI mechanism, right? Retention product. If the same SOCl2 in presence of pyridine, SN2 product, inversion product. If it is pyridine and dioxirane, SN2 occurs 2 times. Product will be retention. Everything you forgot. What is this? Reaction with thionyl chloride. Alcohols with SOCl2. What is this? Intramolecular nucleophilic substitution mechanism. Retention in product. Then alcohol with SOCl2 in presence of pyridine. Inversion in configuration. Reaction proceed via SN2 mechanism. Right? If you take another nucleophile also, then again you will get retention product because SN2 happens 2 times. Right? Response, sir. Now, one more thing. NGP also, neighboring group participation in substitution. Right? For example, say this. NGP. Neighboring group participation. In this case, reaction proceed with very high kinetics. So reaction occurs very fast compared to remaining oil. For example, I am taking CH3, CH, Br, CO, O minus. Can I call it as alpha halo acids? This is alpha carbon, this is alpha halo acid. Correct? Now, if it is allowed to react with any base, alpha halo acids, or alpha halo esters, in presence of base. Even if I take acid, in presence of base, what happens? Base will remove this H plus. Correct or not? Base will remove this H plus and forms anion. Right? That's why directly I am writing it. Directly I am writing that anion. So I am writing it as C double bond O minus. If I take ester also, esters undergo hydrolysis to form again same species. Now observe what happened. This within the molecule will show substitution. As nucleophile is present within the molecule, in all these cases, nucleophile has to come from outside. Here, nucleophile is already present within the molecule, right? So that's why it is called adjacent group, neighboring group participation in substitution, right? Now, what is the product? CH3, CH, C double bond O. Correct? This O minus will attack, making this Br2 leave. Now, base will attack again. Base will attack over this, making this to open. So product will be CH3, CH, OH, COO minus. Indirectly, what we have done? Indirectly, Br is replaced by OH. In this reaction, indirectly, Br is replaced by OH or not? So substitution only, right? But what happened? Neighboring group is interfered in this substitution, and hence rate of reaction will be very high. Rate of reaction will be high due to NGP, neighboring group participation. Any questions, sir, in this? Online, respond. Do you have any questions about this one?
No, sir.
Substitution reactions.
No, sir.
Now I'm talking about second one. Reaction with metals. Reaction with metals. How alkyl halides react with metals? Already you know one reaction. Wood reaction. What is Wood reaction? Alkyl halides reaction with metals only, na? Right? Respond. So I'm writing one statement. Alkyl halides react with metals in presence of dry ether. Alkyl halides react with metals in presence of dry ether. To form organometallic compounds. What are organometallic compounds? There will be bond between metal and carbon. So metal carbon bond exists. We call them as organometallic compounds. All organometallic compounds are good sources of R minus. Correct or not? All organometallic compounds are good sources of R minus, right? So, for example, I am taking CH3, CH2Br, allowed to react with lithium in presence of dry ether. What will be the product, sir? LiBr is gone. Product will be CH3, CH2, Li, correct? Plus LiBr. Same way, if it is magnesium, CH3, CH2Br, allowed to react with magnesium in presence of dry ether. Now, what is the product? CH3, CH2, MgBr. So we call this one as Grignard reagent, organomagnesium compound, magnesium halides, Grignard reagents. All Grignard reagents are all organometallic compounds are good sources of R minus. Good sources of R minus. This R minus may act as nucleophile or may act as base. If there is acidic hydrogen, R minus behave as base. If it is any positively charged species, then R minus acts as nucleophile. If there is any polarity, R minus can act as nucleophile. Response, sir. So this can act as base, can act as nucleophile. I think we have seen such reactions. No, we have not seen it, but I remember like we have seen it. Okay, let me complete that. Now, I am talking about Grignard reagent acting as base. Grignard reagent act as base. Right? I am talking about Grignard reagent means nothing but R minus I am talking about. R minus acting as base. Right? For example, say this. All Grignard reagents are unstable in presence of Grignard reagents, not only Grignard reagent, all organometallic compounds are unstable in presence of acidic hydrogen. They are unstable in presence of acidic hydrogen. For example, I am taking RMgX allowed to react with water. I am allowing it to react with water H2O. In this, do hydrogen is present on more electronegative atom or not? Then hydrogen can exist as H plus. Then what this R minus will do? R minus will go and take that H plus. If R minus takes H plus, what will be the product? RH, alkane. And what is the other product? Mg, OH, X. Now R minus is taking H plus means R minus is acting as base or not? So wherever acidic hydrogen is present, R minus act as base. Same way I am taking ammonia, NH3. Nitrogen is also more electronegative. H2S. H2S also acid or not? Weak acid, na H2S also. H plus, HS minus. Right? RSH. RSH. Hydrogen is also present on more acidic, more electronegative atom. Alcohols, ROH. Acids, RCOOH. Alkynes, RC triple bond CH. All these species have hydrogen on more electronegative atom. If it is a triple bond carbon, percentage character is high, more electronegative. Therefore, this hydrogen is also acidic. So in all these cases, what Grignard reagent or organometallic compound do? You will go and take H plus. So in all these cases, only one product. What is it? Alkane. So here also you will get RH, 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 RH. Now what will be the other product? Now what is the other product here? Mg, NH2X, Mg, HSX, correct? Mg, RSX, correct or not? Here, Mg, ORX. Here Mg O CO R X. Correct. Cationic part. H plus gone here. Remaining anionic part should come here. So here Mg C triple bond C R X. Any questions, sir, in this? Respond online. Do you have any questions in it?
No, sir.
No, sir.
Now, Grignard reagent acting as nucleophile. Acting as nucleophile. What do you mean by nucleophilicity? Ability of nucleophile to attack, or nucleophilic nature of nucleophile is called nucleophilicity. Right? Respond, sir. Reactivity of nucleophile is called as nucleophilicity. Right? Which nucleophile behaves as, or which type of species behave as better nucleophile? Which can act as better nucleophile? Condition 1. Negatively charged species will be better nucleophile than neutral species. Right? For example, if I write OH minus, nucleophilicity is greater than H2O. Response, sir. OH minus is better nucleophile than H2O. Similarly, HES minus is better nucleophile than H2S. Can I call them as conjugate bases? Conjugate bases are better nucleophile than species. H2O conjugate base is OH minus, na? Correct? So I'm writing the same point. Conjugate bases are better nucleophilicity. In a period from left to right. What happens to nucleophilicity? In a period from left to right, nucleophilicity decreases. In a period from left to right, nucleophilicity. Listen, weak bases are better leaving groups. Will you accept it or not? Don't trust me. Just I will do one thing. I will make one statement. Right? From that statement, I will try to bring. Among HF, don't write. First listen. HCl, HBr, HI. Which is strong acid? Right. Very good. This is strong acid. Because weaker bond energy. So it gives I minus. Strong acids conjugate bases weak. So it is weak. Right? Now CH3F, CH3Br, Cl, Br, I. Which bond will break readily? This bond will break readily. Means from here I minus will leave easily. Now tell me, weak conjugate bases are good leaving groups. Correct? Correct or not? So if it is good leaving group, what about F minus? Poor leaving group. Correct? Any questions? Now, in a group from top to bottom, what happens to ability to go and attack? Decreases. Correct or not? Respond. I think we discussed this statement. If a negative charge is present over same element, one minute, where we have seen this in reaction mechanism. I think so. I have posted this reaction mechanism notes. Now see this. In reaction mechanism, we discussed about that nucleophilicity. Here we discussed about NGP also, neighboring group participation. Right? Observe nucleophilicity, affinity for carbon, kinetic factor. Nucleophilicity and basicity order is the same when they have same nucleophilic site. Means if O is common, if O is the donor, basic nature order and nucleophilicity order are same. If donor sites are different, if they belongs to same period, first we are discussing about belongs to same period. Check the point here. Belongs to same period. Then nucleophilicity order is same as basic nature order. So in a period from carbon to nitrogen, nitrogen to fluorine, in a period from left to right, what happens to? This is acidic nature. HF is strong acid, therefore its conjugate base is weak. What I am saying, nucleophilicity order is same as basic nature. So F minus is weak base, means nucleophilicity order also least. Therefore, in a period from left to right, what happens to nucleophilicity order? Decreases. CH3 minus, NH minus, OH minus, F minus. Right? Correct or not? With carbon, nitrogen, if I instead of this one, I am taking OH minus, oxygen, then fluorine. Now, in a group from top to bottom, which is better nucleophile, what we discussed it? Nucleophilicity order is the reverse of basic nature order. This is basic nature order. Right? HA is strong acid, therefore its conjugate base is weak. So I minus is weak. So it is weak base. Therefore, what about nucleophilicity? Reverse. Where is it? Nucleophilicity order is reverse of basic nature order. Right? So that's why I'm writing in a small way. In a period from left to right, as electronegativity increases, nucleophilicity decreases. Correct, sir? Example, CH3 minus, NH2 minus, OH minus, EF minus. So which is weak? Right? Next, in a group from top to bottom, what I will write? In a group from top to bottom, nucleophilicity top to bottom decreases or increases? Just now we have seen, man. Nucleophilicity order and basicity order are same. In a period from left to right, reverse. In a group from top to bottom, nucleophilicity order and basic nature order are same. Correct? HA is strong acid, therefore I minus is weak base. If I minus is weak base, I minus is weak nucleophile. I minus is willing to leave. Means what is its ability to attack? Less. Correct or not? So nucleophilicity decreases with atomic number. Okay, with atomic weight. As atomic weight increases, nucleophilicity decreases, right? So example, F minus greater than, Cl minus greater than, Br minus greater than, I minus. Response, sir. So I am writing one more point there. Weak bases are better leaving groups. Weak bases are better leaving groups. Any questions about these statements? Do you have any questions in this statement? All these statements are clear? Now I am seeing one example. One example I am taking. I am taking aldehyde. Aldehyde allowed to react with Grignard reagent or MgBr. So it is good source of R minus and you will get Mg plus here. Now among carbon and oxygen, which is more electronegative. So electrons try to go towards oxygen and carbon gets. Then R minus now behave as nucleophile because there is no acidic hydrogen. If acidic hydrogen is present, R minus will go and take that H plus. And if it is COOH, then R minus will take H plus. It is not COH now. It is aldehyde. There is no acidic hydrogen. If it is not having any acidic hydrogen, R minus will act as nucleophile. So it will go and attack here. This bond will shift. Product will be CH3 CR O minus MgBr. Correct, sir? If I add water on hydrolysis, what happens? If I add H3O plus, so H plus comes here, MgBrOH goes out. So you will get H3 CHROH. Response, sir, you will get alcohol. Correct or not? So in these cases, nucleophile R minus is acting as nucleophile or not? Right? One more point. Jervitinov's. Have we discussed about the statement Jervitinov's reaction? Just read this statement. What is Jervitinov's reaction? Quantitative chemical test used to determine presence of number of active hydrogens, means number of acidic hydrogens. Jervitinov's method is nothing but to find number of acidic hydrogens. So in a given molecule, if I add excess of Grignard reagent, every Grignard reagent molecule will take one acidic hydrogen, right? So if you get 10 moles of alkane, 10 moles of alkane gas, means in the given organic compound, 10 acidic hydrogens are present. We call that method as Jervitinov's method. So I am taking that as a note. Jervitinov's reaction. So this Jervitinov's reaction is used to determine number of acidic hydrogens. For example, I'm taking glycerol. Glycerol means it will have 3 OH groups or not. How many acidic hydrogens are there? How many acidic hydrogens? 3. So if this is allowed to react with excess of methyl magnesium bromide in excess quantity, then you will get 3 moles of methane, correct or not? Every CH3 minus will go and take H plus. So 3 acidic hydrogens are there, therefore you will get 3 moles of methane and you will get CH2, CH, CH2, OMGBr, correct? If this reacts with acid, again you will get glycerol only, right? And if this is allowed to react with acid, again MgOHBr and OH, you will get glycerol back, right? So to identify number of acidic hydrogens in glycerol, add excess amount of Grignard reagent and calculate number of moles of methane obtained. If you get 3 moles of methane, 3 acidic hydrogens. 10 moles of methane, 10 acidic hydrogens. We call this method as Jervitinov's method. Response, sir. Any questions in it? Online, someone respond.
No, sir.
No,
No,
sir.
sir.
In case of glycerol, one very, very important reaction is there, sir. Very, very important reaction. If a glycerol is allowed to react with HI, acid, alcohols in presence of acid, what they will do? Alcohols in presence of acids. A group's reaction, what you have done? Not alcohol with acid, carboxylic acid, inorganic acid, HX, HCl. If it ethyl alcohol allowed to react with HCl in presence of ZnCl2. Groove's reaction, what you will get? Alkyl halide. Correct? Response, sir. So CH2OH, CHOH, CH2OH. Glycerol allowed to react with HI in excess quantity. What happens now? First, H plus will go on to attack over OH. H2O is eliminated, you will get carbocation. Then I minus will go and attack. Correct or not? Right? Response, sir. So what should be the product? Product will be CH2 I. Respond. Correct or not? Again CHI. Again CH2I. So 3 moles of HI is used to get this one. But if we have iodines on adjacent carbons, immediately I2 will eliminate. All reactions of alkenes with HI are reversible. Respond. Right? So iodine is larger in size. So if iodines are present on adjacent carbons, they will repel. Therefore, I2 will be eliminated to form double bond. So product will be I2 is gone. So product will be CH2 double bond CH CH2I. Now this will react with HI again. First H plus will go and attack over alkene. Addition reaction. H plus will go and attack over this. You will get secondary carbocation. Then I minus will come there. So product becomes CH3, CHI, CH2I. Again adjacent two iodines are there. So what happened? Again I2 is gone. So product will be CH3, CH, double bond, CH2. Again it will react with HI. Product will be CH3, CH, I, CH3. Respond. Right? What we generally expect, alcohols with hydrogen halides, we will expect alkyl halides, right? If they have 3 OH groups, we expect 3 iodines. But what is the product? Isopropyl iodide, that too on middle carbon, right? is the product. Very, very important reaction. Any questions, sir, in this? Respond. Do you have any questions online?
No, sir.
No, sir.
So we are done with
No, sir.
reaction. Yes, sir. Right. We are done with reaction with metals. Right? Oh, important thing we missed. We discussed only Grignard reagent. There are other reactions with metals, na? Urji reaction, right? So next slide reading. Urji reaction. Tell sir, what is Urji reaction? Shall I directly write the reaction?
Yes, sir.
So 2 moles of REX in presence of sodium diether. What you will get? R type alkane, because this will break to form R radical. R radical will combine with another R radical to form R type alkane plus 2 NaX. Right? Now, by this method, methane cannot be obtained. Acceptable or not?
Yes, sir.
And Wood reaction is suitable for symmetrical alkanes, right? Or is symmetrical, both must be same, then it is called symmetrical. If it is unsymmetrical, then you will get many products. Or for example, say this. I am taking one example. CH3, CH2, Br, CH3, I will write CH3Br. I will not increase the chain length. In presence of sodium diether. What you will get? This can combine with itself to form butane. So one product is butane. 1, 2, 3, 4. Plus methane will combine with methane to form ethane, another product. Plus ethane will combine with methane to form propane. These two will combine. This radical will combine with that radical. Plus when you have ethyl radicals can undergo disproportionation also. Two ethyl radicals. From one ethyl radical, H radical can transfer to this. From here to here, if H radical got transferred, then what is left? You will get CH2 radical, correct? And this will convert into CH3. This means nothing but CH2 double bond CH2. You can get alkene also. So you can get ethane and alkene. Can I call it as a disproportionation product? Or one H radical transferred from here to here. Loss of hydrogen is called oxidation. Gain of hydrogen is called reduction. So plus disproportionation products also obtained. Right? So that's why I'm writing yield is less in unsymmetrical alkyl halides. Because you are getting many byproducts. Right? So Uji reaction is preferred. Therefore, it is preferred for symmetrical alkanes. Will you understand, sir? It is preferred to prepare symmetrical alkanes. Clear? Response, sir? So I am not discussing further. No. Franklin reaction. What is Franklin reaction? Franklin reaction. Instead of sodium, if I use zinc, then it is called Franklin. 2Rex heated in presence of zinc and dry ether. So product will be RR alkane plus ZnX2. Correct, sir? Next, fitting. Fitting reaction. What is fitting reaction? Aryl halides. Fitting reaction. Instead of alkyl halides, if I use aryl halides, heated in presence of sodium dry ether, you will get biphenyl. Hey, it is fitting. Would fitting means one alkyl, one aryl. Would fitting. So one Rx allowed to react with aryl halide. Again, same in presence of sodium dry ether. Then it is called Wurtz fitting. Next, Ullmann reaction. What is Ullmann reaction? Heated in presence of copper. Ullmann. U-L-L. Ullmann's reaction. So same thing, heated in presence of copper. Particularly iodates on heating use biphenyls. This is called Ullmann. Next, Corey house synthesis. Tell me what is Corey house synthesis? Already we discussed it. Gilman reagent, right? React with alkyl halides or benzyl halides to form alkanes. Corey house synthesis. I am taking Rex. When heated with lithium, then you will get RLi. This RLi allowed to react with copper halide. Then you will get R2CuLi. This when allowed to react with R prime X. Then you will get R prime alkane. Now condition is this alkyl halide is there now. In this alkyl halide, it should not be tertiary alkyl halide, right? And it should not be phenyl halide. Right? Because R minus should go and attack over this to remove this X. So this reaction will proceed via SN2. And from this R minus should go and attack here, making this X2 leave, na? Right? So reaction should proceed via SN2, right? If it is a tertiary alkyl halide, SN2 fails. If it is tertiary, SN2 fails. Reason, crowding. And if it is tertiary, alkyl halide, how R minus will go and attack? Not possible now because crowding is there. So in case of tertiary, you will get alkenes. In case of tertiary, that R minus will behave as acid. Sorry, behave as base. This R minus will go and take H plus. Then this bond will shift here. X will be lost. So we will get alkene. Right? So that's why to form alkane, this may be either primary or secondary or maybe benzyl, but it should not be. It should not be tertiary or phenyl. If it is a tertiary, in case of tertiary, you will get alkene. Will you understand, sir, if I write like this? If this is the tertiary, you will get alkene. Now, in case of the initial case, this RX may be either primary or secondary or tertiary or allyl or phenyl or benzyl, etc. It can be anything. While you are preparing Grignard reagent or organometallic compound, what is this organic compound? This is called Gilman's reagent. To prepare Gilman's reagent, you can use any alkyl halide. But to form alkane, Gilman's reagent should react with either primary or secondary or benzyl. Means where SN2 is favorable, only such reactions will lead to formation of alkane. If SN2 fails, alkane formation fails. Right? Now, one more point. Gilman's reagent does not react with. Gilman's reagent does not react with nitro compounds, cyanides, ketones. So in these cases also, Gilman's reagent will not. Any questions? Respond. Any questions in this?
No, sir.
Next. So we are done with reaction with metals, right? Alkyl halides reaction with metals. Next. Once open your target place. Go to page number 71. Go to page number 71. So methods of preparation of haloalkanes from alcohols, all methods we have done, I think. We have already seen this. Then page number 76, halogen exchange, Finkelstein reaction, SWOT reaction, done. Then page number 77, preparation of haloarenes, done, from diazonium salts. Then have we solved that exercise? So that exercise we will solve. Then physical properties, then chemical properties, nucleophilic substitution reactions, done. Response, sir. Next, page number 82, leaving group ability. Which are better leaving groups? Simple statement. Weak bases are better leaving groups. Over. Next, optical isomerism, elements of symmetry. All these things are long back over. R configuration, S configuration, dextrorotatory, levorotatory, CIP rules. Whether it is clockwise, anti-clockwise, all that nonsense. Enantiomers, diastereomers, all these points are already over. Then directly page number 88, SN2 mechanism, 89 SN1 mechanism, 90 NGP, neighboring group participation. Response, sir. Then page number 93, elimination reactions, 94 even elimination, 96 reaction with metals, done. Next heading, reduction of haloalkanes. So we are going to see reduction of haloalkanes. Then page number 99, Guccifitic, Ullmann. Over. So first we will see reduction of haloalkanes. And then exercise directly I will go to 103. Right? First we will see reduction of alkyl halides. And then I will see that solve that numericals. Then directly I will go to page number 103, polyhalogen compounds. Okay? That is it. Nucleophilic substitution, two mechanisms. Addition, elimination, elimination, addition. Or a benzyl mechanism, size substitution. Done or not? What, man? Yesterday only we discussed this point. Okay, I will discuss one more time and we will move it. So next heading, reduction of alkyl halides. So point number 4, point number 3, reduction of alkyl halides. There are many reagents, sir, for reducing alkyl halides. Among all reducing agents, one reducing agent is best. HA in presence of red phosphorus. Any functional group will be reduced to alkane. So no need to discuss. Response, sir. Right? So HA in presence of red phosphorus, one reducing agent. Directly, can I take an example? Right? RX in presence of HI red phosphorus. What you will get? RH plus Pi3. Next. RX in presence of any reducing agents forms RH plus HX. This is nothing but reducing agents. In presence of reducing agents. Examples of reducing agents. Zinc in presence of HCl. What happens? Zinc in presence of HCl. Zinc reacts with HCl to form ZnCl2 plus. That H will come here. Zinc in presence of NaOH. Zinc in presence of ethyl alcohol. Zinc in presence of acetic acid. Response, sir. All these are nothing but what type of metal zinc is? Amphoteric. Means it can react with acid as well as base. So zinc in presence of acetic acid, zinc acetate plus hydrogen, zinc with NaOH, sodium zincate, Na2ZnO2 plus H2. Correct? So in all cases, you will get hydrogen. So metal acids are metal bases. Correct? Any questions, sir? Zinc copper couple in presence of ethyl alcohol. Aluminium amalgam in presence of ethyl alcohol. Right? Lithium aluminum hydride. Sodium borohydride. Trialkyl tin hydride. Respond. All these are good reducing agents. In case of lithium aluminum hydride, one specialty we discussed. Yesterday only we discussed. Lithium aluminum hydride will reduce all functional groups into alcohols. Alkyl halides will convert into alkanes. Remaining functional groups will convert into alcohols. But it will not reduce carbon-carbon double bond. It will reduce carbon-carbon double bond if and only if it is adjacent to benzene. Right? Lithium aluminum hydride. Here I am writing, sir. Lithium aluminum hydride. If it is aldehyde group will convert to alcohol. Keto group converts to alcohol. And wherever pi bond is there, remove that pi bond, add H and H. That's all. Here also I am removing pi bond and adding H and H. Right? Respond. Carboxylic acid. Again, you will get alcohol. Cyanides. Here I will get amines. Right? Yamides. Here also I will get amines. Any questions? Respond. So instead of all this nonsense, or a important point we discussed, you missed. Alkyl halides converts to alkanes. Our chapter is about that, right? So one important point, note. Lithium aluminum hydride do not reduce carbon-carbon double bond unless it is adjacent to benzene ring. Example, I am taking cinnamaldehyde. Cinnamaldehyde. In presence of lithium aluminum hydride. Now tell the product. Now this carbon-carbon double bond also will be reduced. And this aldehyde group also will be reduced to alcohol. Over. Any questions? Respond. Only benzene, not any other cases. Done, sir. Next. First, before going further, we'll solve the numericals and then I will go to the next concept, right? Problem is from this book I cannot take, right? Whether your iTutor is working. Completely they closed iTutor. Huh? Because if it is iTutor, I can drag and paste the total image. Hey, working man. Hey, it is student's ID only. I logged in with some student's ID. Attendance sheet. It is working. So in that I am opening alkyl and aryl halides. So from there, I am taking 24-25 book. What is the page number? 1. Exercise 1. This one only. Oh, I can't take that image.
Sir, in student ID, we can take it. Sir.
How can I take this image? I have one more idea. Is there? Yes. I am converting image to PDF. Wherever questions are there, those pages I will take here. Cheating. This page also I will take. Then exercise 9.2. Oh, 1 minute. From question number 9. 1 minute. Here also one question is there. Then again one question mixed. Exercise 9.4 also. Sorry. So many questions they gave as exercise, huh? Nine 9.5 also I will take. Over. Right, remaining all are additional information. Can I take this step 1, step 2 also? Okay, will not take much time. Fatafat I will take. Yes, sir. Yes, sir. అయిపోయిందా వెళ్తున్నారా రైట్ సార్ Wait, so many questions are there in this chapter? Huh? 170 questions are? Enough. Alright, step 3 you solve. Huh? Step 3 also so many questions maybe. Yes, yes, yes. Also, let me copy. Go and come back quickly. Oh, over. Create PDF. ISO, generally gas only. If it is iodides and bromides, they are solids. Right? Up to 3-membered, they are all gases only, na? One minute, I will come to that. ಒಂದು ಆಗದು ಒಂದು ಆಗದು ఈలోపు ఈ బుక్ లోంచి క్వశ్చన్ PDF తీసేస్తే అయిపోయాయి.
సరే సార్ అది లీవ్ అప్లై చేస్తాను.
అప్లై చేస్తుంది. ఎప్పుడు వేస్తున్నారు? ఇవాళ హాఫ్ డేనా? ఓకే సరే సరే. ఏం
లేట్ అయిపోయింది.
ఓకే ఓకే ఓకే.
ఇట్లా కూర్చోవాలి.
ఓకే ఓకే.
నాకు ఫ్యామిలీ స్లీవ్ పూర్తిగా
వాళ్ళు వెళ్ళిపోతుంది.
సరే సరే.
Open. It is downloading it as a .download something. That file name, if I change now, it is opening. So now I will close this. This also will close. I have to insert it, right? Perfect. Right. Shall we start? Break over? Huh? Hey, you went for break, na? Hey, went man. Now see, sir. See this first question. Following method cannot be considered suitable for preparation of alkyl halides. In which case you will not get alkyl halides. What is this one? Alcohols with PX3. Alcohols with PCl3 or PCl5. You will get RX plus H3PO3. Correct? If it is PCl5, POCl3. If it is a phenol, in case of phenol with PCl5, you will get chlorobenzene, but it is not major. It is not major. Correct or not? Along with that, you will get POCl3, but this POCl3 will react with phenol again, losing H here and chlorine here. So 3 times it will react to form P double bond O phenyl. Special case we discussed it. Yes or no? Correct or not? So phenol with PCl5, you will get this product, but this will react with phenol again. Right? Other than that, if it is other alcohols with PCl5, then what you will get? RCl plus POCl3. Right? So option 2, you will get it. Next, alkenes with HX, addition reaction. Correct or not? So I can get CH3, CHX, CH3, because secondary carbocation is more stable if it is. Next, alcohol with HX and ZnCl2, Lucas. Right? If it is primary, secondary. If it is tertiary, follows SN1 mechanism. If it is primary, secondary, SN2 mechanism. Correct or not? If it is a tertiary, no need of ZnCl2 also. Directly it can react with HX. So perfectly you will get alkanes. Halogenation of alkanes. Also you will get alkyl halides, but yield will not be good. That's why it is not best suitable method. You will get many byproducts. So following method cannot be considered as suitable for preparation of alkyl halides. So I will not consider option 1. Here also you can prepare alkyl halides, but you will get many byproducts. Clear? Online. Yes, sir. Response, sir.
Yes, sir.
Now come to next one. Which of the following reagent cannot produce only chloride? Which of the following reagent cannot produce only chloride? If it is HBr in presence of ZnCl2, what you will get? Alkyl bromide. PCl5, yes, you can get chloride. PCl3, you will get SOCl2. What is the name of reaction? Dargens. Reaction proceed via SNI mechanism. Correct? So answer should be option 3. Next. Some alkene, correct? With HBr. Alkene with HBr, sir. CH3, C, CH3, CH3. This is CH3 thrice C, correct? Bond, CH, double bond, CH2 with HBr. Now, what should be the product first? Which will attack? First H plus will go and attack. If H plus attack on this carbon, you will get secondary carbocation. Right? So first you will get CH plus CH3, secondary carbocation. Now carbocation rearrangement occurs. Methyl group will migrate from here to here. Right? So what we call it as 1,2 methyl shift. So when that methyl got shifted, what you will get? CH3, C positive charge. You will get tertiary carbocation now. Tertiary is more stable, right? Then Br will go and attack there. Marconi Kapf product. If it is HBr in terms of peroxide, anti-Marconi Kapf product. So what should be the answer now? Option 1. Any questions online? Do you have any questions, sir?
No, sir.
Next question, sir. Which of the following reactions does not proceed through radical mechanism, in which case radical mechanism does not happen. Or NBS in terms of H nu. Specialty. Allylic or benzylic substitution, correct? Response, sir. Now double bonds, next carbon is called allylic bond. Allylic carbon, na? This carbon is called allylic carbon. So you can get Br radical there, correct? So product will be CH3, CH, Br, CH double bond CH2 plus another possible product. First you will get radical here. Then this pi bond can shift to form another radical here. Are you able to understand? First you will get CH3, CH radical, CH double bond CH2. Is it possible or not? N-bromosexaramide, man, radical mechanism. Correct? After getting this radical, can I shift this pi bond? I will do homolytic cleavage. Then I will get radical here, radical here. Between these two radicals, I can form a double bond. So I may get CH3, CH double bond CH. Here CH2Br. Possible? So I will get two possible products. Of course, which is more stable? Which is major? This is major. Reason? Secondary radicals are more stable. Correct? What is this one? Alkene with HBr and peroxide. Karash effect or peroxide effect. What you will get? You will get CH3. They have not given any other carbon. There is no difference between both carbons. Br can attack on any one now. So CH3, CH2, Br. Definitely radical mechanism. Now, CCl in presence of peroxide. Karash effect or peroxide effect is only observed in HBr and peroxide. HF, HCl, HI. In these three cases, peroxide effect fails. Means in option 3, radical mechanism failed. Correct? Huh? Response, sir. I say something. Now, in first case, chlorine in presence of sunlight. Chlorine in presence of sunlight. What it will do? It will go and attack over CH3. Correct? Huh? If it is chlorine in presence of iron or chlorine in presence of FeCl3 or chlorine in presence of ZnCl2, if there is any Lewis acid, then chlorine will attack on benzene ring. What type of group CH3 is? Ring activating, ortho para directing. So you will get chlorine at ortho position or para position. If it is chlorine in presence of iron or FeCl3, then I will get this as it is. This becomes major because this is ortho para directing. They have not given Lewis acid. Only sunlight means radical mechanism. If it is radical mechanism, what should happen? I will get CH2Cl. Correct? So in these three cases, radical mechanism is observed, but in this case, radical mechanism fails. Reason? They have given DCl. Right? This is a DCl. Correct? D plus Cl minus. Open target booklet, man. Then it is visible. It is blurred. Image is blurred, I think. You cannot see properly. So in case of HF, HCl, HI, Karash effect fails. Or simply I will write no Karash effect. So answer is option 3. Any questions online?
Yes, sir.
Now, diazonium chloride with HF and BF3. What you will get? HF and BF3. You will get N2 plus BF4 minus. Right? HF BF3 will combine to form H plus BF4 minus. Correct? That H plus Cl minus gone out as HCl. You will get this one. This on heating gives fluorobenzene. What is this name reaction? Boltzmann reaction. Or a preparation of alkyl aryl halides from diazonium salts. Boltzmann reaction. So answer is they want major final product. Fluorobenzene is the major final product. Respond. Next, sir. Alkene with NBS, N-bromohexaramide. What should happen? N-bromohexaramide, man. Allylic or benzylic substitution. So can I say radical here is more stable because it is in conjugation on both sides, right? Say something. Say something, sir. Yes or no? Right? So product will be. I am writing double bond here. Next carbon, I am writing Br. One possible product. Another possible product. After getting radical, I am shifting this bond. If I shift this bond, I may get radical here also. Possible? If I shift that bond this side, after getting radical here, if I shift that bond to this side, another possibility. We are here, right? Response, sir. Plus another possibility. Is this carbon is also allylic carbon to this double bond or not? For this double bond, this is the allylic carbon. So you can get bromine there also. So these are the four possible products. Now they are asking which is major product? Which is major? This is 4. This is 1. This is 3. This is 2. Now tell me which is major. Is it 2? Right? Response, sir. Here, listen one thing. 1-2 addition, 1-4 addition, 1-2 addition, 1-4 addition, right? When dienes allowed to react with HBr at lower temperatures, 1-2 addition happens, right? If it occurs at higher temperatures, 1-4 addition occurs. Kinetically stable product, thermodynamically stable product. But this is radical. See this. Let me continue this. Let me explain that. I am adding HBr. Only HBr, sir. Not peroxide. Then H plus will go on attack. First H plus will go on attack. You will get positive charge here. Br goes there. Means H and B added on adjacent carbons. That's why we call it as 1,2 product. On first carbon and second carbon, H and Br got added. So this is 1,2 addition product. Instead, after getting H plus here, you will get carbocation here. Then I am shifting pi bond. Then I will get positive charge here. I am adding Br minus there. Are you able to understand? First I am adding H plus, man. On adding H plus, I will get positive charge here or not? If I add Br minus directly here, first product. If it undergo resonance, now I will get positive charge here. Then I can add Br minus there also. Then I call it as 1,4 addition. Hydrogen is added to first carbon. Bromine is added to last carbon. So I call it as 1,4 addition. 1,4 addition product is called thermodynamically stable product. This is called kinetically stable product. I call it as KCP, kinetically controlled product. TCP, thermodynamically controlled product. This happens at high temperature. This happens at low temperature. If they have not mentioned any temperature, means room temperature. If it is room temperature, thermodynamically stable product. Right? Here, kinetically stable product. Are you able to understand? Now, this is happening via electrophile. H plus is attacking. But in this case, radical is attacking. Na? Correct or not? So in case of radical, if radical is formed here, then it is secondary radical and it is in conjugation with 2 pi bonds. If you get radical here, it is in conjugation with 2 pi bonds in the same direction. Here, 2 pi bonds in the same direction. Here, 1 pi bond. But it is having 2 pi bonds in the same direction, but it is primary radical. This is secondary radical. Or if I am getting radical here, this is secondary radical. Both pi bonds are in conjugation in the same direction. This is primary radical, same direction. This is primary radical, but conjugation with only 1 pi bond. Here, secondary radical conjugation with 2 pi bonds. So which is more stable? Generally, we expect second product. Check the answer. Wait. Answer is option third. Reason. Both are in conjugation in the same direction. We call this as cross conjugation. Or if you get a radical here. If you get a radical here. Now I have conjugation in this direction as well as conjugation in this direction. When you are having conjugation in this direction, conjugation of this pi bond got interrupted. Or when this is involved, this cannot show conjugation. Na? When that is involved, this cannot show conjugation, correct? So both are cross conjugating each other, both are disturbing each other. But in this case, so I got radical here. This can shift here. At the same time, this also can shift here, na? Showing conjugation in the same direction. There is no interference, right? And it is a secondary radical. In this case also, continuous conjugation, extension of conjugation. What we call it as extension of conjugation, but primary. This is also extension of conjugation, but secondary, which is more stable. Secondary is more stable. So which is answer now? Are you able to understand? Therefore, this becomes major. No cross conjugation. It is extension of conjugation. Any questions, sir? Right? Now again, alcohol with SOCl2. What you will get? Instead of OH, you will get chlorine plus SO2 plus HCl. In product, number of gaseous, wait, 3, wait. This is also gas only, no? Answer should be 3, no? Isopropyl chloride. Oh, liquid. Okay. Up to ethyl chloride. Fluoride, chloride, bromide, ethyl chloride are gases at room temperature. Methyl iodide and up to C18 are colorless, sweet smelling liquids. So isopropyl chloride becomes liquid. So this is liquid. This is gas, this is gas. So answer must be 2. Respond, sir. Next one. The structure of this, okay, shows. Do it have chiral carbon or not? This is also chiral carbon. And this shows geometrical isomerism. And because of this double bond, it shows geometrical isomerism. Totally, how many stereogenic centers? 3. Then number of stereoisomers are 8. Correct? I will get 8 stereoisomers. It shows geometrical isomerism, optical isomerism. So answer is option 3. What? Oh, these two are hydrogens. Okay. Then this is not chiral. This is chiral. Then it is 2 square. 4. 2 stereogenic centers. Right? Response, sir. Any questions in it? Actually, it shows metamerism also. Metamerism is a structural isomerism, na? Right? Then I can change the position of O between these two carbons. I can keep O between these two carbons. Metamerism means over the functional group, carbon chain length should change. Then they are called as metamers. So obviously, this compound will show many metameric forms. So metamerism also correct. But I feel like they are talking about geometrical optical. It can show metamerism also. Right? So answer will be option 2 as well as 3. If it is single answer type, okay, I'm preferring option 3. They might have not given this word metamerism. Right? Metamerism is structural isomerism, man. Right? So it can show functional isomerism or not. No. Which of the following is absolute configuration of this carbon at 2 and 3? At this carbon and this carbon, what is the absolute configuration? Which is priority? 1, 2, below 3. Means 1, 2, 3. What is this order? Anti-clockwise. Anti-clockwise means yes, but hydrogen horizontal. So this is R. If hydrogen is vertical, I will keep it as it is. Now, for below 1, first priority. First priority is O. Second priority above. Third priority below. So 1, 2, 3. What is this order? Again, anti-clockwise. But hydrogen is again horizontal. So again R. So answer is RR. RR. So answer is option 1. Response, sir. Next. How many stereoisomers are possible for compounds X and Y, respectively? Can I say it is meso? Okay. It has 2 chiral carbons, right? 2 chiral carbons and it is even in number. Number of stereoisomers equal to 2 power n minus 1 plus 2 power n by 2 minus 1. Response, sir. 2 power n minus 1 plus 2 power n by 2 minus 1. Or if it is even, 1 minute. Reaction mechanism. Not reaction mechanism. Stereoisomerism. See this one? If molecule is unsymmetrical, then number of optically active forms are 2 power n. If I divide with 2, number of enantiomeric pairs, number of mesoforms are 0. Right? If it is symmetrical, then I need to check whether it is even or odd. If it is even, number of optically active forms 2 power n minus 1. Number of mesoforms 2 power n by 2 minus 1. Totally how many stereoisomers? 2 power n minus 1 plus 2 power n by 2 minus 1. Right? If it is odd, number of stereoisomers exactly reverse. Is 2 power n minus 1? I will write here. Instead of n by 2 minus 1, I will write n minus 1 by 2 and I will subtract both to have optically active forms. Clear? So whether it is symmetrical or not. At that side C have PQR, this side carbon also have PQR. So is it symmetrical molecule or not? Even number of chiral carbons. So total number of stereoisomers they are asking. So formula 2 power n minus 1 plus 2 power n by 2 minus 1. So what is that value? N is 2. So 2 plus 1 means 3. Only one option. Right? Check for the next case. Because of double bond, this is one stereogenic center. Because of chiral carbon, another stereogenic center. So two stereogenic centers and unsymmetrical molecule. So 2 power n. So 4. Respond. Next, sir. Specific rotation of an optically pure compound X is plus 40. If it is 100% pure, plus 40. In a reaction, compound X is obtained through a series of chemical reactions. If the specific rotation of solution is minus 20, what is the percentage of LIGO form? See, if it is a pure plus form, I will write D form. Then it is plus 40. Then its mirror image, if it is pure L form, minus 40. Now I am mixing them in proper ratio such that the mixture is having minus 20. Correct? Response, sir. So what can be L value? What can be D value? Can I say in this minus 40, 20 got cancelled? Right? Means if I take only minus 20 left means I am taking this is 75%, this has 25%, sir. Now I am taking this 25%, this 75%, man. What happened? 25% cancels 25%. 50% of L left. Then answer will be minus 20. Correct or not? So what is the formula? Enantiomeric excess equal to D minus L form upon D plus L into 100. Enantiomeric excess equal to D minus L upon D plus L into 100. Right? I am getting minus 20. Means how much L form is excess? 50% of L form is excess. Response, sir. So 50 equal to, I don't know D value or L value. So I am writing D minus L upon D plus L will be 100 only. Right? D form, L form, if I add, total becomes 100% or not? Into 100. So D minus L equal to 50. Means what must be D value, what must be L value? 75, 25. Correct or not? So what they are asking? What is the percentage of LIGO form? 75. Next. If X and Y are two unknown substituents, then which of the following is true? Now what they are saying, this is methyl, this is hydrogen, this is X, this is Y. If X is H, Y is D. If X is H, Y is deuterium, it is not optically active. Correct, sir? Then it is not optically active. Optically inactive means option 1 is correct. If X is D, Y is T. X is D, Y is T. Yes, chiral carbon. Then optically active, correct. If X is D, Y is H. Then it is optically inactive because there is plane of symmetry. Response, sir. Plane of symmetry. I can cut the molecule like this. This side H, that side H. D is in my plane. My plane will be like this. D will be in my plane. Correct or not? So answer All of this. Next one. Online. Are you following or not?
Yes, sir.
Yes, sir.
Yes, sir.
Again, I'm saying organic chemistry. At the same time, you need to read the theory followed by solving numericals. Right? If you are not in touch with this, after 1 week, when you start studying, you will feel everything as new. Right? So simultaneously, you need to read it. Next one. Order of reactivities among the following towards conversion of alcohols through SN1 mechanism. SN1 reactions means what are the conditions for SN1? Rate of reaction depends upon only concentration of alkyl halide. Order of reaction is 1 followed by a carbocation mechanism. Correct or not? More stable carbocations prefer more stable reaction. Carbocations favor SN1. Solvent must be polar protic solvent. Polar protic solvent. Yes, sir. Respond. Now, among all of them, which forms stable carbocation? What is carbocation in first case? Tertiary. Here, secondary, allyl. Oh, sorry, there is no methyl, I think. Is it allyl or not? And double bonds, next carbon is having positive charge. Allyl carbocation. Then this one is secondary, which is more stable. Tertiary more stable than secondary, means allyl than secondary. So answer must be 1 greater than 2 greater than 3. No option, huh? No, correct only, no? First option. 1 greater than 2 greater than 3. This we have seen. Strongest nucleophile among the following. Which is strongest nucleophile? Generally, negatively charged species are good nucleophiles. Correct? Now, among these two, I need to check. And both have oxygen donors. Right? So one is ethyl alcohol and another is water. Among ethyl alcohol and water, which is more acidic? Water. Oh, except methanol. All alcohols are less acidic than water. Special case. Among all alcohols, only methanol is more acidic than water. Just a moment. That also where we might have discussed electronic effects. Huh? In class 11th in GOC, we discussed it, man. In electronic effects. Acidic nature of alcohols. See. Note. All carboxylic acids are more acidic than methanol. Methanol is the only alcohol more acidic than water. Water is more acidic than all alcohols. Right? So among water and ethyl alcohol, which is more acidic? So if it is more acidic, then its conjugate base is weak. So OH minus is weaker base. Then CH3, CH2 minus. Weak bases are right. So which is better nucleophile now? Which is better nucleophile? This must be better nucleophile now then. Response, sir. Correct or not? Think in this way. What type of group CH3, CH2 is? Donating group. Because of it, what happens to negative charge over oxygen? Increases. Correct? Means it is better nucleophile or not? Correct? This statement also we have seen 1 minute. I think we have taken same example in reaction mechanism. Just a moment, I will show that also. Same example we have taken, I think so. Just a moment, just a moment. See this. When they have same nucleophilic site, means the same atom as donor. Observe this example. In all these cases, O minus is the donor, right? Then basic nature order and nucleophilicity order are same. C2H5O minus is more nucleophilic than OH minus. Same example they have here. Response, sir. Next one. Correct order of nucleophilicity. This also just now we have seen. Now compare to neutral and anions, which is better nucleophile among these two? Means this option is wrong. Here also, this is better, so wrong. Among these two, this is correct. Now here, OH minus and F minus. In a period from left to right, nucleophilicity increases, and as electronegativity increases, nucleophilicity increases. So F minus is better than. Oh, correct only na this also. Hey, this option also correct, man.
Sir, nucleophilicity decreases across period, no, sir.
Whether I have given increases or decreases, what statement I gave? Decreases only, yeah. Then okay. That means OH minus. Okay, basicity, yeah. Basicity and nucleophilicity orders are reverse in a period from left to right. Right. Next one, sir. The correct order of following towards SN2. SN2, man. Less crowding. What are the conditions favor SN2? Single step mechanism or concerted mechanism. Correct? Less hindrance. Correct. Good nucleophile. Good leaving group. Nucleophile also should be good. Otherwise, conjugate base elimination mechanism will have. And what type of solvent? Polar aprotic solvent like DMS4 dimethyl formamide, right? Polar aprotic and Walden inversion, reverse inversion product. In case of SN1, racemization. Inversion slightly dominates retention. In case of SN1, racemization, but retention, inversion slightly dominate retention. Correct, sir? Now in this case, here SN2 will not occur. No SN2. Reason, sir? In order to that, this oxygen has a donating group. If it donates, electron density over this carbon increases. Then how nucleophile should go and attack? So to make nucleophile to attack, here I should get positive charge, then only nucleophile can go and attack. So here substitution will never happen. Next, in this case, possible or not? Nucleophile perfectly will go and attack. Right? Now, one more condition. Anti-periplanar. What is anti-periplanar? Leaving group and in nucleophile. Both should be at 180 degree apart. Now, compared to chloride, bromide is better leaving group. Correct? Response, sir. Now, benzene ring acts as withdrawing group because of these two carbon. This is sp3 carbon, this is sp2 carbon. sp2 carbon will pull electron cloud towards it. So this carbon is getting partial positive charge. means nucleophile can attack easily. So C greater than, A greater than, B greater than D. In case of D, it will never occur. So answer should be C, A, B, D, fourth option. Response, sir. Online. Are you following or not?
Yes, sir.
Sir, but in C, steric hindrance will not occur, sir.
Hey, in all the three cases, there is no steric hindrance. All are primary only, na? All are primary only. This is also primary, right?
Ah, yes, sir. Okay.
Right. Next, decreasing order of reactivity of the following organic compounds towards AgNO3. Aromatic. See this. Here, if Cl minus goes out, what you will get? You will get positive charge here. Double bond. OMe. Is it aromatic ring or not? Response are Huckel's 4n plus 2 pi electron rule. Here also I will get positive charge. This is also aromatic. Whereas here I will get positive charge. Here also I will get positive charge, but here minus M group is there. Minus I group is there. So minus I groups destabilize positive charges. Means here it should not occur. So D is lowest, least stable. Aromatic compounds are more stable. So D less than, C less than. Now among these two, which is more stable? Here it shows resonance also. Correct? It is interfering that number of conjugations will increase. So better I will go for B greater than, A greater than. But I have a doubt here. Check the option. B, A, C, D. Answer whether it is A or not. Check, sir. Check, check, check. B, A, C, D. Correct? Huh? Right. Because these two form aromatic here along with aromatic ring. What type of group this is? Donating group. What donating groups do? Here you will get satisfied octet. When this oxygen donate lone pair, see this. When this pi bond got shifted, then I get positive charge here. Correct? Now this oxygen can donate lone pair of electrons. When that oxygen donate lone pair of electrons, what you will get? You will get a double bond, methyl, positive charge, lone pair. In this form, do all atoms are having octet configuration or not? This oxygen is also having octet configuration. So we got a satisfied octet. Among all cations, satisfied octets will be more stable than aromatic. Is it clear? So that's why second is more stable. Now coming to next one. Which of the following compounds will form precipitate with AgNO3? You are getting precipitate with AgNO3 means either AgI or AgBr should precipitate, right? So among them, which is more stable carbocation? Option 1, satisfied octet. Just now we have seen. From here, if Br is gone, what you will get? Correct or not? Now this oxygen can donate lone pair of electrons to form satisfied octet. Correct? Oh, here also possible, huh? Here also it is possible, man. Because here you will get positive charge. Nitrogen can donate lone pair, making positive charge over N. This is also possible. Here also it is possible. N. You got positive charge over N. Here also it is possible. Right? Now here O methyl N Here there is positive charge. It can show resonance. After forming a resonating structure, it will be stable, but before that, primary carbocation. Here primary means highly unstable, means it is gone, it is least. Nitrogen is better donor, no? Carbon's empty orbital is in 2p. Then answer option 2 is also correct then. Array check sir whether they gave you answer 1 or not. Array check once. Whether they gave 1 or 2. Second option. Because nitrogen is better donor than oxygen. Nitrogen's lone pair is in, okay, oxygen's also in 2p, but compared to oxygen, nitrogen is less electronegative. So compared to oxygen, nitrogen will donate electrons readily. Correct? So here also satisfied octet is possible. Correct? So 2 greater than, 1 greater than, 3 greater than, 4. That should be the answer. Right? In both cases, I am getting satisfied octet. Compared to oxygen, nitrogen can donate electrons more readily. So octet got satisfied here also. Clear? Next one. Correct order of reactivity of the given chlorides with the acetate in acetic acid. Chlorides should react with acetate in presence of acetic acid. Means, can I say CH3CO minus should replace alkyl halide? Correct or sir? To form ester. I say something. Is nucleophilic substitution or not? Named reaction. Bergman Simonini. Correct or not? Now what they are asking? Which is correct order? Where that nucleophile go and replace it readily? This is happening via SN2 mechanism. So we need to check where SN2 reaction occurs readily. Right? Now check sir. Where SN2 occurs readily? This is in conjugation. This is not in conjugation. Here also it is not in conjugation. Here it is in conjugation. If it is in conjugation, it occurs readily. Here also it is in conjugation, means it also occurs readily. Means option 2 is wrong. Not in conjugation. Not in conjugation. In conjugation. Here also in conjugation. But crowding is here. Here crowding is not there. Means this should occur readily. Means answer should be option 3. See what I am doing. Here methyl is there. Here I am taking chlorine. Right? Now CH3COO minus. I am making CH3CO minus to attack. I can make this to attack here, making this Cl2 leave. Right? Now, one more possibility. This bond can shift here, making Cl2 leave to form tertiary carbocation. Possible or not? When this pi bond got shifted, Cl is gone, you get tertiary carbocation. Tertiary carbocation is more stable. Then nucleophile can go and attack there. Correct or not? But this is crowded. No, trigonal planar can attack either above the plane as below the plane. Response, sir. That can attack above the plane as well as below the plane because this is sp2 hybridization, no? So no hindrance. Means this should occur readily. So answer must be option 3. Check. Response, sir. Next, AgCN. Which is donor now? Nitrogen will be donor. Silver carbon bond will not be ionized. If nitrogen is donor, product will be CH3 ENC isocyanate. So answer is option 2. Next one, increasing order of SN1. Right. SN1 means more stable carbocation. Where carbocation is more stable? In all cases, you will get benzyl carbocation. Here also iodine. What type of group this is? Plus M group. Here also plus M. Among methyl and O-methyl. This is better plus M group because oxygen have lone pair of electrons. So answer must be D greater than, C greater than. Here at meta position, plus M do not operate. This is at meta position or not? Plus M do not operate. Instead, minus I effect will operate. When oxygen is more electronegative means inductive effect will operate. Correct or not? So this is least. So A greater than B. So answer D, C, A, B. Option 1. Check. Next one, sir. It can form more stable carbocation or not? First Br is gone, you got carbocation here. Then methyl group can shift. Then tertiary carbocation. Then you will get alcohol, OH here. So answer must be, reaction should proceed via SN1 mechanism. Respond. But problem is, first primary carbocation, how it is formed. After forming primary carbocation, rearrangement occurs. But first, how primary carbocation will form, right? So SN2 also can occur. SN2 occur, but option 3 is wrong. Via SN1, 3 will not be possible. And if it undergoes SN1, I should get this as the product. Means this is correct. SN2 will not happen here. SN2 will happen here. Response, sir. SN2 means at the same BR, OH minus should go on attack. Correct? Response, sir. Here, this is leaving group. OH minus should go on attack here. Correct? This is primary. But what about next carbon? Next carbon is having 3 substituents. Means steric effect will be there to some extent. Steric hindrance will be there or not because of these neighboring groups. OH minus cannot attack over this carbon easily. Means SN2 to some extent hindrance is there to some extent. But SN1 is happening readily. So I prefer answer as option 4. But SN2 also should occur. Both are equally possible. Solvent is aqueous. What type of solvent then? Polar protic solvent. Polar protic solvents prefer SN1. If it is polar aprotic solvent, I might have given SN2 as major. So I will go for option 4. Check, sir. What they gave. Response, sir. Right? Say something. Next one. Methanol, sir. They're adding methanol. Again, what type of solvent? Polar protic again. And it can give H plus or not? So again, polar protic solvent means reaction proceed via. Again, SN1 means first Br is gone. If a Br is gone, you will get secondary carbocation. Then hydride shift. 1 to hydride shift. So we will get tertiary carbocation. Over the tertiary carbocation, OCH3 group will attack. So answer is first option. Now, major product in this case. NaOH, C2H5, right. See, C2H5OH plus NaOH. Now, can I say this NaOH can pull H plus here to form C2H5O minus Na plus? No, because NaOH cannot remove H plus from ethanol. Sodium will remove. Ethanol is less acidic than water, right? If it is less acidic than water, how OH minus will go and pull H plus easily? If it is sodium metal, then I will write C2H5OH with the sodium metal forms C2H5O minus Na plus half H2. Then this acts as nucleophile that will go and attack. Correct or not? Now this acts as solvent. C2H5OH now act as solvent. Now which acts as nucleophile? OH minus should act as nucleophile now. Na plus OH minus. So OH minus should go and attack. So OH minus can go and attack at different positions. See this? There is double bond. I am making OH minus to attack here, making this pi bond to shift here, making Cl to leave. Possible or not? What do we call it as SN2 prime? Then product will be, I can have double bond here and OH here. Means option 2 is possible. Response, sir. We are not heating. If I don't heat, elimination do not occur. If I heat, answer should be option 4. If I heat, then what it is? Alcoholic NaOH. Response, sir. Is it alcoholic KOH? Aqueous KOH shows substitution. Alcoholic KOH shows elimination. This is also same like alcoholic KOH, na? Right? So we have to show some elimination. If I show elimination, I have to form double bond here. Then both will be in conjugation. Means option 4 is possible. Correct or not? So if it is a beta elimination, I should get 4 as the option. But they are not heating. They are not heating means they are providing room temperature. They are not giving any temperature means at room temperature. So at room temperature also elimination is preferred, means option 4 is possible. So I will go for 4th option. Are you able to understand? If they mention low temperature, then instead of elimination, I will go to 2nd option, substitution. As they have not mentioned, room temperature is provided, means heating indirectly you are providing, means it prefers elimination. Respond. Online.
Yes, sir.
What is sodium
Yes,
iodide
sir.
in terms of acetone? What is this reaction? Finkelstein. What is this one? Iodine. Huh? Here also iodine. Here also iodine. Huh? 2 iodines. Huh? Where? This is CH3. Huh? This is CH3. This is iodine. Huh? Okay. In Finkelstein, alkyl chlorides and alkyl bromides are replaced to form alkyl iodides. Here you have given already iodine, right? Means let me write. So I am writing this hydrogen here, deuterium here, methyl here. For convenience, let me write like this. Here I am writing iodine. Here I am writing methyl. Towards me, I am writing hydrogen. Here also towards me, I am writing hydrogen. Into the board, I am writing deuterium. Into the board, I am writing deuterium, right? Now, Na plus I minus, right? So I minus should go and pull this I plus. Then what you will get? Carbocation. And if it pull, no, anion you will get, no? Elimination is also not possible. Means only possibility is I minus should go and attack here, making this iodine to leave. One possibility, right? Then what I should get? Then this hydrogen comes below the plane. This deuterium comes below the plane. This iodine comes above the plane, correct? Response, sir. I will get this one, correct? Now, again, I minus can come below and make these two leave. Means I will get a mixture of these two. Correct? Hey, not enantiomers. This is already chiral. I am not disturbing chirality of this carbon. Chirality of this carbon is fixed. Only if it is R, this is also R. Only if it is R, this is S. Then what are they? Diastereomers, not enantiomers. So answer must be diastereomers. Check, sir. What they give? Second option, huh? Response, sir. Major product A and B of the following reaction. KCN DMSO. What is this, sir? Dimethyl sulfoxide. SN2. Polar aprotic solvent. DMF, dimethyl formamide or DMSO. So Cn minus will go and replace I. So product will be. What is product now? This is double bond O. Over this carbon, you will have cyanide now. Correct? Now hydrogen in presence of palladium. Means you are doing a reduction. Then cyanide will be reduced to. Cyanide will be reduced to alkene. Correct, sir? Now, what about ketone? Ketone also should be reduced to alcohol, but hydrogen in presence of palladium has some exceptions, sir. What is that exception? Hydrogen in presence of palladium. It preferentially reduce. Yes, I should get alcohol. Both has to be gone. Means answer should be fourth option. Because all pi bonds should be reduced. Because it is hydrogen in presence of nickel, hydrogen in presence of platinum, hydrogen in presence of palladium. Savatier-Sanderens reduction. Hydrogen in presence of nickel. All pi bonds will be removed and add hydrogens. Right? Next case. That is enough. Now come to exercise 9.4, sir. KOH, ethanol and reflex. What you are doing? Alcoholic KOH and followed by reflex means heating. Means elimination. Right? Elimination means I will remove Br and H. Two possibilities. I can remove H and Br between these two carbons or these two carbons. If I remove between these two, this is one product. If I remove from here, I will get this product. This is called Hoffman product. This is called Sagejeff product. Generally, always which is major? Sagejeff will be major.
Sagejeff product.
Hoffman is major only in few cases. What are they? Poor living group, quaternary ammonium salts. If a gamma carbon is quaternary, right? Bulky base, alcohols when heated with thorium oxide. In these 5 cases, you will get Hauptmann product as major. In all other cases, Sedgef is major. Respond. So what should be the answer now? Answer should be option 4. Correct, sir? Right? There are so many questions are there. Huh? I am also getting irritation, man. How many questions I solved? 27. Okay. Another. Okay, leave it. Let's stop the discussion of questions. Right? We will discuss later. Right. We'll go to theory again. What we need to discuss, sir? Reaction with? What we need to discuss? Poly halo compounds. That also, right? Reaction with haloarenes. Yes, you mentioned it. Listen, sir. Reaction with haloarenes, sir. Listen. There is one method called Dow's method. Right? Ratching process, Dow's method. 2 methods. First, we are discussing about Dow's method. Chlorobenzene, when it is heated in presence of base at high temperature and high pressure, then OH minus will go and replace chlorine to form phenol. Right? This type of reaction occurs in 2 ways. There are 2 mechanisms for it. Mechanism 1. One mechanism, sir. We call it as addition elimination mechanism. First you will get phenoxide followed by water, you will get phenol. Because you are taking base now, so you will get O minus. Later it will convert into phenol. If it is NaOH, later it will convert into phenol. Nothing there. Right? So we are not bothered about this. First, how that OH is replacing it. So addition elimination mechanism. So in this mechanism, if it is halogen, added nucleophile, because halogen is more electronegative. As halogen is more electronegative, what about this carbon? Carbon gets partial positive charge. So nucleophile will go and attack over that, making this pi bond to shift. So what you will get now? You will get X and you will get nucleophile. You will get negative charge. Now it undergoes resonance. But anyhow, finally it will be this only. Now when this come back, making this X to leave. Now what is the product? Instead of X, you got nucleophile. So nucleophile is substituted in the place of X or not in benzene ring. That's why it is called nucleophilic aromatic substitution. Right? So first nucleophile got added, then X got eliminated. That's why it is called addition elimination mechanism. If partial positive charge over this carbon enhances, then what happens to rate of reaction? Means fluoro, chloro, bromo, iodo, where reaction occurs more readily. Fluoro. Generally, in all cases, alkyl iodide will replace easily. In general, in all cases, this bond becomes weak. So we'll remove I with nucleophile in all cases, but not in this case. In case of benzene, this is the reactivity order. Other than benzene, if we take any CH3I, CH3Br, CH3Cl, CH3F. Now, which is more reactive means CH3I is more reactive because this bond will break ready. Are you able to understand? Here, addition elimination mechanism. First, nucleophile will attack because of partial positive charge. Now, if there is any withdrawing group, then NO2, two NO2 groups, three NO2 groups. Among these two, which will react towards this mechanism more readily? Which will react more? Because NO2 group will enhance partial charge here. Therefore, nucleophile will go and attack here readily. So this will react more readily than this, Right? This is addition elimination mechanism. Next one, elimination addition mechanism, sir. Elimination addition mechanism. Now, how this reaction occurs? See this. Now, I am taking same chlorobenzene, allowed to react with NaNH2. Means I am writing it as Na plus NaH2 minus. NaH2 minus also act as base. NaH2 minus also act as base. Right? Now, what it will do is, this is the carbon on which chlorine is present. This NaH2 minus first pulls this H plus out, making this bond to shift and making the Cl to leave. So what happened first? First elimination happened or not? From here H is gone. From here Cl is gone. HCl is gone. So what you will get? Benzene. Is it benzene or not? Right? In benzene, all carbons are sp2 hybridized. Correct? No. Why I marked this carbon? This is the carbon from which chlorine is lost. Correct? Now, what is gone out? Ammonia. Now that ammonia can donate lone pair electrons back to this position as well as this position also. Both are equally possible. That's why what we got as sign substitution. Sign substitution. If it attacks here, then what happens? If it attacks, this bond will shift, that H will come here. So you will get NH2. Or I may get NH2 here. Both seems to be same, but different actually. Reason, here NH2 attacked on the carbon from which chlorine is lost. Here NH2 attacked on the carbon adjacent to it. Are you able to understand? Both are equally possible. This is elimination addition mechanism. This is addition elimination. This is elimination addition. Both cases, substitution happened over benzene ring. That's why it is called nucleophilic aromatic substitution reactions. Clear? Any questions in it? Response, sir. Sometimes they will ask you question in this way. I am taking CH3 here, Br here, allowed to react with Na and H2. Now what is the product? What happens first? First NaH2 minus will go and pull H plus from here. Correct? So product will be triple bond here, CH3 here, double bond, marking this carbon. Right? Response, sir. Correct or not? From here H is gone, bond is shifted, Br is gone. Now ammonia has to donate lone pair of electrons either this position or this position. So what is the product? If it attack here, this bond will be shifted, leads to product formation, that is ortho product. If NH2 attacks here, then which is major meta. Which is preferred? Ortho or meta? Which is preferred? When NiH2 attacked here, I will get anion here, correct? Response, sir. When NiH2 attacked here, you will get negative charge here or not? If NiH2 attacks here, you will get negative charge here. Response, sir. Correct or not? Now, what type of group methyl is? Plus I. What type of group NiH2 is? Minus I. This negative charge is away from methyl. Here negative charge is adjacent to methyl. Among these two anions, which is stable anion? First one or second one? What type of groups both are? Donating groups. Correct? Donating group will increase charge at ortho and para positions. Already negative charge is there. If they increase negative charge further, stability decreases. Correct or not? Respond. So, which should be major? Ortho product must be major. This should not form. Means ortho product should be major. Correct? Accepted or not? Now see this. This is, I think, previous JEE advanced question. Ortho halo toluene, sir. Benzene in substituted what we got as nucleophilic substitution in nucleophilic aromatic substitution in substituted benzenes. This one, sir. Oh, that is para, na? Where is ortho? This one, sir. Observation 2. In this example, ortho and meta products are formed, but none of the para is formed. Correct or not? Just now we discussed, na? What this K plus NiH2 minus, we have taken NaNiH2, right? It will pull H plus from here, you will get benzene. Corresponding product is there. But major, they are not saying major. Which is major? Oh, they escaped from this. Now, sir, see what you got. If it is ortho, If it is ortho, you got both ortho and meta. Since this places the intermediate anion closer to the electron withdrawing group. Where it is withdrawing group, man? Oh, they are talking about below one. We have to see above one. Orthochlorotoluene gives a mixture of meta and ortho. So both are possible. Now I am taking CF3. In case of CF3, what type of group CF3 is? Withdrawing group. Strong minus I group. If it is strong minus I group, what happens? Negative charge here becomes stable. Are you able to understand? Instead of CH3, if it is CF3 minus, CF3 group. If it is CF3 group, negative charge here becomes more stable because it is strong minus I group. Response, sir. Correct or not? As this is strong minus I group, you are getting negative charge means this becomes major. So meta becomes major if it is CF3. Clear? Right? If it is a donating group, then ortho becomes major. Is it clear? Now, if it is at para position, for example, if it is bromine, here I am taking CH3. Now, sir, now what I should get? I can remove H either this side or that side. Means I will get benzene like this. Now, NH2 minus can attack either here or here. Both are equally possible. Respond. Both are equally possible. Then, if it attacks here, I will get negative charge here. If it attacks here, I will get negative charge here. In which case, minus A effect of methyl is weak. In which case, minus I effect of methyl is weak. As the distance increases, sorry, plus I. Methyl is plus I, na? Methyl is plus I. As the distance increases, plus I effect decreases. Because of plus I, what happens to negative charge increases, na? So in these two, here negative charge becomes more, means it becomes less stable, means this becomes major. So this is major product. This is minor product. Correct, decreases. Because of plus I, negative charge should increase, na? If negative charge increases, stability decreases. Correct or not? Are you able to understand? So this is how these corresponding reactions occur, right? So in next class, we will see what is the concept, sir? Polyhalogen compounds. Yes, sir. One more reaction is also there. One more reaction is there. Reimer-Timer and haloform reaction that we will discuss in polyhalo compounds, because carbene is the intermediate. Carbene intermediate is formed from polyhalo derivatives. That's why here we will discuss. But phenol reacts with what? Chloroform and NaOH. So chloroform is nothing but alkyl halide, no? Yes, sir. I will end the session, sir. You can leave. Again, I am saying solve those target booklet questions properly, right? Is it okay if I conduct classes on weekdays as well as weekends? What okay, man? This week,
sir.
how many people came? Huh? Hardly 10 people from weekend. Hardly 10 people. If you are not coming, what is the use of taking class? At least can you come on Friday, Saturday, Sunday? Not every day. What? Means anyhow I am taking class on Wednesday. Anyhow you are not coming. That is also no use. So that's why at least Friday, Saturday, Sunday. Not more than that. Array, if you accept, you must have to come. Shall we do? Remaining days I will not disturb. For weekday students also, I will schedule classes only on Fridays. Right? Array, I completed surface chemistry. Amines already over. Biomolecules over. Only polymers, chemistry in everyday life. Aldehydes, ketones, carboxylic acids, alcohols, phenols, ethers. If I complete these 4 chapters, total syllabus is over. What, sir? Amines already over. For weekday students only, man. Along with that batch, along with that batch, I completed total amines. Reaction mechanism, carbohydrates, hormones, everything is over. Biomolecules, everything is over. Okay. Amines, I will teach you separately. Oh, all weekday students also, half of them attended, half of them not attended. Okay, leave it. Amines I will teach separately. Again, I will teach. Small chapter only, easy chapter. Right? What you will do? Coming Wednesday, will you come to class or I have to schedule on Friday? Your choice. If you say Friday, you must have to come. Online. Shall I schedule on Friday, Saturday, Sunday? I will not disturb you on remaining days.
Okay, sir.
Yes, sir.
Yes,
Okay,
sir. Yes, sir.
One day extra. Along with Saturday, Sunday, anyhow you are coming. One day extra, Saturday, Friday. Right? Okay, sir, I will end the session.